Hello, I'm going to give you an update on the status of WASI support for .NET. Now, as you may know, WASI is a standard for running WebAssembly in non-browser scenarios, for example, on a server or embedded into a desktop app. And we've had a prototype version of a .NET SDK for WASI for about a year now. Well, the great news is this is being cleaned up, expanded and stabilized and being brought into the box as part of .NET 8. So let me show you how you can get started doing WASI for real with a current .NET 8 preview. The first thing you need to do is install the new Wasi-Experimental workload. Now, I've already got that installed, as you can see, and that workload comes with a project template. If you search for it, search for WASI, you'll see WASI console here. So I'm going to create a project using that template. Very good. Okay, now let's go and have a look at the files that are in there. In fact, it's slightly easier if I show you in VS Code, so let's pop that open. And if we look in the CS proj, you can see it's the same as a normal .NET 8 project, except it has this wasi-wasm runtime identifier. And that will change how the compilation works. If we look in Program CS, all it does by default is just log something to console. So I'm going to change that slightly so that it also logs the operating system architecture so we can verify that it's running on WebAssembly. Now let's compile and run that. So we'll use a regular .NET build. Obviously you could use VS if you wanted instead. That's just going to do a normal .NET build, but it adds some extra files to your normal assembly so we can run it in WebAssembly. So if I do a .NET run, you'll see that it's doing a bit of extra stuff. It's starting the app in something called wasm app host, which launches wasmtime, and that's a runner for server-side WebAssembly. And it logs a bit of other information, but the main thing is here it's actually showing us our actual console output. Cool. But I don't want to use .NET Run all the time. I'm going to show you that we can run directly on wasmtime. So if I go into the directory that contains that, and I'll just copy and paste this command and run that directly, and you can see that produces the same console output as before. Now, these files, the way this works by default is it's got a standard build of the .NET runtime for WebAssembly, and that can load and run your DLLs. But it's not really what I want, because I want to produce a single WASM file that contains my whole application. So I'm adding this WASM single file bundle property to my CS proj, and with that, the build output will be structured slightly differently. A way that I think is a bit more useful. In fact, we probably want to make this the default. So that builds as normal, except now it adds an extra stage where it uses Clang within the Wasi-Sdk to combine everything into a single WebAssembly file. So if we look in that app bundle directory again, you'll see we've now got myapp.wasm. It's quite big, that's because there's no trimming in this mode, but that contains both the runtime and all our application assemblies, so we can run the whole thing in a self-contained way directly on a standard runner like wasmtime. Alright, so if you're interested, please give it a go. Now there are still some rough edges and some missing features, for example the ability to define arbitrary imports and exports so that you can work with third-party APIs, but that is all coming. Alright, so you can run .NET on server-side WebAssembly. Great, but what's the point of doing that? Are we saying you should now start deploying your existing regular applications as WebAssembly into WASI environments? No, we're not saying that. That's not the point. Your existing applications can already run normally. You don't need WebAssembly for that. The point of what we're doing with WASI support in .NET 8 is to enable platform creators to create new kinds of platforms, new kinds of applications, and to take .NET to places that it's never been before. Maybe you can use the flexibility of this to create a new kind of app platform. So, to give you an idea, I'm now going to show you 3 examples of how this technology allows you to run .NET in ways that you would not have been able to do before. The first example is for isolation. You could create a .NET WebAssembly instance inside a regular .NET application if you want to run some code you don't totally trust or to guarantee it has no side effects. For example, here's a web server that responds to all requests on the root URL by returning this string to display the request count and the current OS architecture. So by default in my browser, you can see my laptop is an x64 machine, and each time I reload, it's updating that static field to increment the request count. Okay, now let's add some isolation. I've added a reference to the .NET Isolator package, an experimental package which uses the Wasi-Sdk to run .NET on WebAssembly inside .NET. And the way to use it is we create an instance of an isolated runtime host that configures things, and then we can create as many .NET runtime instances as we like using that. And then we can make a call from regular .NET into WebAssembly.NET in a very easy way, just using a C# lambda method. So the body of that lambda is going to run on WebAssembly, even though the rest of the application is not. So now when I reload, you'll see that that body of the lambda is on WASM, and the request count still goes up because each request is sharing the same isolated runtime. But if I was to take that variable and move it into the request delegate, now every request gets its own separate runtime instance. So every time I reload, the counter does not seem to go up, and every request is isolated from every other one. The second example is a little bit crazier. If you were to compile your ASP.NET Core server to WebAssembly, then obviously you could run it on the server inside a WebAssembly runner. But you know what else can run WebAssembly is browsers. So you could run your web server inside your browser. I showed this example last year, so I'm not going to dwell on it too much, but what this is a regular ASP.NET Core server application with Razor pages. It's not Blazor, just regular server app, so it has methods for handling post requests, doing validation, redirections, that sort of thing, and it's built using the Wasi-Sdk. That's the prototype version of the real thing I'm now showing you. And since that's built for WebAssembly, it's possible to run it inside a browser. So here it is. It's actually hosted on GitHub Pages, which, as you may know, only handles static file hosting, so it can't work with ASP.NET Core Server normally, but this is entirely inside the browser. You can see here in the console log that the browser is actually running the server and displaying its console output here, and we can see the WebAssembly file that's running. This is the ASP.NET Core server built for WebAssembly, and the way it's wired up to the browser is using this service worker, which intercepts requests from the browser and handles them by passing them into the ASP.NET Core app on WebAssembly. The third example is a bit wild. I'm going to show you how an application could migrate across the internet while it's running, preserving all its memory. Now here I've got a Blazor application. It's an app that we first showed a few years ago when we introduced Blazor, but it's working a little differently now. So first, I'll just build up a little bit of state here. So you can see I've added some flights to my shortlist. That's cool. But this is not running on WebAssembly in the browser. I'll prove that. First, you can see there's no WASM files, but there is a WebSocket connection to the server. So it's like Blazor server. Every time I click something, messages go to the server. It's all evaluated there and streamed over the connection. So what happens if I shut down the server? Well, let's find out. Just like any Blazor server app, if the server is gone, then the browser is going to try to reconnect. And normally it would be pointless because when the server comes back, all the state will have been lost anyway, and so we wouldn't be able to continue. But in this case, when we reconnect, we don't lose our state. We can just carry on from where we were before. How does that work? Well, this is actually WebAssembly on the server, and there's a separate app instance for each user, which makes it very easy to store the entire heap state on disk. So if the server goes down and then comes back up, well, we can just reload the heap and carry on as if nothing happened. But that's not the most interesting thing. The most interesting thing is what happens if I click this magic yellow button at the top. After I click that, I'm going to go and shut the server down once again. But this time notice the browser is not trying to reconnect. In fact, the app is still working. It's got all its state and it can just keep going, even though there's no server at the other end to work with. How is that? Well, the WebAssembly app has migrated across the internet into the browser while it was running. And to show you that more clearly, I'll do it again, but this time with the DevTools open. Initially, we've got our WebSocket connection, but no WebAssembly files have been loaded. But when I click the yellow button, see that the WebAssembly file is loaded into the browser. But not just that, also there's a request to heap here, which returns a 650 kilobyte file in this case, and that contains the full heap state for this particular user, so the application can just carry on inside the browser. Now those are just illustrations. For the last two at least, there are some real practical problems with actually doing it for real, so we're not planning to do so, but I am looking forward to seeing what you invent and what you do with WASI. That's all for now, so get a .NET 8 preview and try out the new Wasi-Experimental workload and let us know how you get on.